Hello everyone, today is December 3rd, 2025, and today we're gonna solve this problem called LeetCode 244 shortest word distance 2. So basically we are given a list of words. So here's one example. This is what's given. And then basically the first input is the function call. So it's gonna call in this way. It's gonna initialize this word instance. Its object is capital word instance. And this word list is gonna pass to the constructor to construct this data structure. And then the second shortest is gonna call the shortest function of this object, and then given two words, coding and practice. It's gonna return 3. So what does this mean? Basically, it's in the list that it was given, it's gonna count the distance between these two words. So here you see coding and practice, their distance is 1. This is practice, and this is 1 and 2 and 3. So the shortest distance between coding and patient and practice is 3. And the next example, it's gonna call shortest and on mates and coding. So let's look at mates and coding. So there are two mates here. There's one here and one here. So this mates go to coding would take a 1 and 2. So the distance will be 2. But this mates go to coding is only 1. So we'll return 1 here. So now let's implement this. So the idea is basically we're gonna, for each of the word, we're gonna build an index first. So basically we can use the word as a key and use a list as its value, and the list is gonna store where the position is in the given list here. So, and then when we are given two words there, so each of the word, we can get the list of its positions there, and then we can compare those positions. So yeah, I'll talk more about that when we get to the point there. So to build up the index, we can use a very handy data structure called defaulted. So we can import this from collections. Import default date. And then in the initialize method, in this init method, we can call a enumerate function. So let's give I and W. So index and word in enumerate function, and given the words date as its input. So this will give us its index and a word. So now we can build up, let's initialize the index first. So let the index be defaulted, and the values type is a list. So this data structure is pretty handy. If some key is already there, then you can read the value out. If the key is not there, it will initialize an empty list. So you can, save a lot of typing, just directly edit the element to a new list if the key was created for the first time. So here, what we can do is index W. So once we call it, then the list is created. If it wasn't there, then we can add its index to it. And because we're gonna do a for loop and start from 0 and all the way to n-1, so by default this word list, the position list is sorted. And this will be a data structure that we use internally. So we call it self.index and self.index so that we can use this self.index inside the whole object there. So when we work on this shortest, the two parameters we have like water1 and water2. So the first step we need to do is to get the position list out. So we can call self index water1 and position 2 self index water2. And we can also initialize a minimum distance variable and set it to be like the infinity, so that whenever we find a smaller number, we'll update this minimum distance. Then, now let's do the comparison. So this part is a little bit tricky. I don't think it's very easy to think of, but I try to explain. So let's set a while loop first. So first of all, let's initialize the index for this position 1 and position 2 equals to 0, 0. So we need to compare these two positions. So while I is less than the length of position 1 and j is less than the length of position 2, then we're gonna compute the distance. So I is looking at the first list and j is looking at the second list. Then we need to compute its distance. So we can update the minimum distance to be the minimum of itself, and also the distance between these two words. So let's take an absolute number. And then we can use like position. So position 1 is a list of like word 1. So it's I minus position 2 is j. So basically for the same word, would this represent the position of word 1 and this represent the position of word 2. And then we can take a difference and we call like a absolute function, so we don't need to worry about the sign. It's always gonna be positive. And then we compare it to the existing minimum distance. If it's smaller, then we update the minimum distance to be the smaller one. Now, the tricky part is like if position 1 I is less than position 2 j, then we're gonna increment I. Otherwise, we'll increment j. So I will explain this in a second, but let's see if we can pass the test. So after the while loop, we compare all the possible minimum distance, then we can just return it. So let's try to run the small test. Yeah, it can run. And okay, the big text phase failed. So let me see if I can fix that. So what's the error here? So it's supposed to be 1 and 2. So AB's distance is 1, and BA's distance should also be 1. So for some reason, maybe like it finds like B and this one. So first of all, let's yeah, I think it's also a good opportunity. Let's just point out the default date to see if it's correct there. So it's just for our debugging purpose, for us to really understand the solution. So for W in self index, so this is like after building the index. This part is just debug. We're gonna print. We're gonna print like a format W, and then this part we're gonna print the self.index W. It's gonna be the dictionary. So yeah, we'll print the index out in this part here. So let's get this example. So for small test case, are we able to edit the test case? Yeah, this is a good test case. Okay, yeah, so we can look at the output here. So A's position is like 0, 1, 2, 3, so that's correct. And C is 1, and B is 2. Okay, so we build out this index correctly. And now we look at the while loop. So, oh, here you go. We should only increment J by 1. That should be able to pass the test there. And now we beat like 24% of the solutions, I think because of the debug statement. Let me comment out this and try again. Yeah, it does improve. Now it beats like 85% of the solution there. So yeah, basically, let me give you an example of like what this part means here. So I think if you're working on this for the first time, make sure to spend some time to really understand the solution. So let's take like a hypothetical example. Let's say the position 1 equal to like a 1 and 4 and 6 maybe. And then position 2 equals like a 2 at 3 at 5. So these are two position lists that we want to compare. So first of all, let's say the pointer is like pointing to 1 and 2. And then we're gonna compare like the distance between the first word and the second word, and the distance is apparently 1 there. And then we need to do the next comparison there. So we have two choices. Let's see, what if we want to move, according to this solution, we are moving the one that with a smaller index here. So the next comparison we're gonna do is like 4 and 2 there. So there's an opportunity that we get a smaller in this sense. So yeah, this is another very good example. Let's say this is 4 and this is 2. So maybe we can see it like a more clear in this way there. So when we're comparing 1 and 2, 1 and 4, we got the distance is 3 there. So this is like has to be like an increment order. Okay, yeah, that's a better example. So now we have two choices there. So from word 1, the first word, to the fourth word, the distance is 3. Then how could we probably like shrink the distance there? So we have two ways. The current solution, we are shrinking it by moving the one that has smaller value. So let's say from 1 to 4. And then now we move it to larger to increase the smaller number so that we're shrinking the distance. We have the opportunity to shrink the distance. Let's say in this sense, 2 and 4 is closer than 1 to 4. So we are shrinking it. And then we keep doing that. However, another choice is that we move the larger number. So when we move like 4 to 5, that's pretty much like guarantee that the distance is larger. So we don't need to do this kind of like comparison. So basically, this is like we have a star, and this is a distance, and this is n. So these are the two words. And then we compare the next word. We want to move the star forward so that we're like comparing the next potential smaller distance there. However, if we instead we want to move n, then we are actually increasing the distance. So we are not checking all the possible minimum distance in that sense there. So yeah, I hope that clear a lot of confusion and can explain the rationale of like this kind of while loop here. So now let's look at the time and space complexity. So for building the index, we go through like each word once. So this should be O of n. We just like iterate from the beginning to the end for each word, and then insert that to like a hash, a default div. Basically, is a hash map. So the space it also takes on, and then when we are performing the lookup here, so this takes O1 to get the two lists out there, and then when comparing the two lists and find out the minimum distance, then this will be O of like the sum of the lengths of the two lists here. So then the final complexity, we don't need a final complexity. Basically, it's two functions. They have different time complexity. This is like time and space O of n, and being like the number of words. And in this function, looking up, then this will equal to O of like the distance of two words there. So in the worst case, it would be like n, because we have like n words here. So it would be also O of n to look things up. And we also have this data structure always in memory. So the space complexity will also be O of n. If you found this video helpful, please smash the like button. It really helps support the channel. And don't forget to subscribe for more content like this. Subscribing also helps the algorithm recommend similar videos to you. Thanks for watching, and I'll see you in the next one.